Welcome to Verifying Trig Identities, example number 3. Remember, the identities that we're currently working with up to this point are the fundamental trig identities, or the reciprocal identities, quotient identities, which are the definitions of tangent and cotangent, Pythagorean identities, which are really key components of this, cofunction identities, a little something I like to refer to as the complementary angles rules of trig functions, and also the even-odd identities, which can also be referred to as the negative angle identities. Alright, so we've got this example in front of us here. We got a couple of fractions that we're trying to add together and show that that is actually equal to 2 secant squared of alpha. That little Greek symbol there for the angle listed is called alpha. Well, I've got two fractions here, and one of the things that I hope you recognize is that the only way I can combine these is if I have a common denominator. Okay, so let's go ahead and try that. We want to create a common denominator here. So on the left hand side here, I'm going to have 1 plus sine of alpha. On the right hand side, I'm going to end up with 1 minus sine of alpha. And this is all going to be over a common denominator of 1 minus sine alpha, 1 plus sine of alpha. Okay. Alright. At this point, we should probably do a little bit of algebraic simplification here. And see what we end up with. If I take 1 plus 1 in the numerator, I end up with 2. If I take sine alpha minus sine alpha, I have 0. So in the numerator, all I have left is 2. What about on the bottom? What can we do in the denominator? Well, I've got that 1 minus sine alpha times 1 plus sine alpha. And to simplify that, I should multiply those two expressions together. And I've got a 1 times 1. I got a plus sine of alpha and a minus sine alpha. So the sine alphas will cancel each other out. And then I have a negative sine alpha times a positive sine alpha. So I end up with a 1 minus sine squared of alpha. Time for a little Pythagorean identity. Pull out your trig identity sheet if you don't already have it in front of you, and just double check it. Make sure you verify Pythagorean identity. Well, the first one we come up with is the sine squared plus cosine squared is equal to 1. So what I have listed here, though, is 1 minus sine squared. So do a little subtraction in the original Pythagorean identity, and you should realize that this is equal to 2 over cosine squared of alpha. And if at all possible, what I need to do now, I take a look at this, and alright, I'm down to one single trig function, which is excellent. And my goal, though, is to get to 2 secant squared of alpha. If you remember, the definition of secant is actually 1 over cosine. So I can rewrite this then as 2 secant squared of alpha using the definition of secant. And that is indeed equal to what we're looking for, which is from our original identity expression there. That is the 2 secant squared alpha. That's all there is to this particular example. You guys have yourself a great day, and take a look for example number 4. The fourth example of verifying trig identities is going to be using some kind of factoring techniques possibly. So tune in for that one, and you guys have yourself a great day.